Welcome everyone. We are what stands between you and that refreshing cold beer. So we'll try to make it quick, fast, and fun. Okay, my name is Raj. In former life, I was a principal SA at AWS. I recently left AWS to take a chance at creating my own startup. And today I'm presenting with my ex-coworker, Rodrigo.
Hey everyone, now I have time to do like a proper introduction other than the lightning talk. So my name is Rodrigo Bersa. I think I met most of you here, and I like to see like a lot of familiar faces from the previous years. I've been presenting here since 2023 and helping people on the organizers. So happy to see like this community growing, and happy to be here again. And today I have like my former partner on AWS, Raj, who is like also like a star on social media.
All right. Okay, so we are going to talk about the age-old debate, velocity meets security. Anyone here from the security team? Okay, we don't bring them anywhere, right? Anyone here from the platform engineering, developer, DevOps team? Right. We go to all the parties. So in today's talk, we thought it will be interesting because both Rodrigo and I have worked with many different customers who are in the same shoes, how they solve some of the security challenges at the same time, deploy products fast, and release features for their customers. So with that, let's get started. So this is the dilemma, or perhaps some sort of false dilemma. The more security you implement, the slower your velocity becomes, right? So as you make your workloads more secure, the developer needs to adhere to some different stuff. You're like, I just want to create a Kubernetes cluster, deploy my workload, and have customers have some fun, right? But security is like, no, you have to use this, use that. So, well, I was a developer before, so I had a lot of fights. What if this does not need to be the case? What if we want to deploy a lot of security controls, at the same time, we also empower developers and the platform teams to go fast as well? So this is the end goal, where you want to implement securely operate security controls. At the same time, you want your developers to experiment, be productive, and do as much self-service as possible. Okay. So we thought we will go with what we saw in the real-world customers. So this is generally the team setup. You will have developer teams, and then you will have SecOps teams. And then the developer teams are in charge of the application layer. So you'll create some code, you will build the code, and then you'll deploy it. And where will you deploy it? You need some sort of infrastructure. And that is maintained by the SecOps team, who are in charge of infrastructure as code tools and processes and of various infrastructures. So where is the bottleneck? So if we look at this typical model, you as a dev team may say, hey, I have a ticket, why don't you give me a Kubernetes cluster? This is what I need as a configuration. And then, this is where I missed my clicker. Another team may say, hey, we want some infrastructure too, maybe Amazon RDS, and I want the security group to be open to the whole internet. Nothing wrong with that, right? So SecOps is like, okay, let me inspect your ticket. Another team comes, more infrastructure. So this is where the bottleneck is, because there are a lot of development teams, they want different kinds of infrastructure, and SecOps needs to go check each of those tickets. So how do we solve it? We can solve this in one way by implementing as much security controls as possible in the automated pipeline. In that way, some of the manual effort is taken away. So if we look at a fundamental CI/CD pipeline, this is what this is. The developers check in the code, and then the code gets built, and it gets deployed. So what if we can implement some of the security controls in the pipeline itself? So developer can check in code, Then you have some sort of authentication that, okay, this pipeline is authorized to pull in the code and do some action on it. You can put some sort of abstraction, as in developers don't need to specify each parameter. You developer don't need to put what AMI it needs to use, or whether it should create a security group open to the whole internet. All those are abstracted and taken care of. Then you have the build from a specific repository. Then you can enforce some of the policies that, okay, this container image must come from this repository, the AMI must be the golden AMI, so on and so forth. And then you can deploy, you can audit trail the deployment to see what's going on. And of course, if you choose blue-green deployment strategy, then you can save the state. So in case you need to roll back, you can roll back. So you may say, okay, Raj, so this solves the problem. Not entirely, right? Because in an actual enterprise, there are many of these pipelines that exist. One team may be using just the app and UI. Another team may need some queues and streams, so their infrastructure will look a little different. The security controls look different. Another team may be using tickets to do networking security IAM, another team doing something else. And to make it even more complex, one team may be using Terraform, another team may be using CloudFormation. So it becomes very difficult to maintain all those security controls, auth, abstraction, policy, state in this heterogeneous number of pipelines. And then it gets magnified by some of the other factors, which is you may need to scale to millions of users. And when you are scaling to millions of users, you need resource isolation. You need consistent security. If something goes wrong, we need observability. We just had a great workshop on Prometheus, right? So we saw how important it is to have metrics and logs. And multi-tenancy, the age-old dilemma whether you should have a separate node for your very special application or separate namespace. So at this point, we are going to bring the superhero of the story. No, not Rodrigo. He is a hero. Kubernetes. Okay, so Kubernetes can help you solve a lot of these challenges. And before we dive deep, we will utilize some of the building block of Kubernetes, which is the declarative infrastructure, built-in security primitives, and auto-scaling capabilities, which leads us to automated secure deployments, lower operational overhead, and faster time to market. So you're like, Raj, you skipped a lot there. You just went from the Kubernetes properties to what it can achieve. So to peel the onion and show under the hood, I'm going to invite Rodrigo on the stage.
So if we take in consideration like what Raj just showed us on the pipelines, all the abstractions, you see there are like a few bottlenecks there other than just the ticketing and the people, right? Like DevSecOps team, platform teams versus a lot of development teams and like that wants to like develop faster and do like a lot of updates. So you can see like the Kubernetes can be that platform that it has like embedded a lot of native capabilities or even like using CNCF landscape tooling to achieve all of those things that we had on the pipelines in a centralized platform. And guess what? We have like a centralized state, which is etcd. We can like store everything there, all the states. So why not use Kubernetes as the main platform to solve all of those things or to be the central point of your platform engineering aspect? So we have like authentication authorization that we saw using RBAC. We saw Cedar that can extend those RBAC powers. We have like the mutation admission policies that can be achieved today with like validation admission policies native from Kubernetes. Also we have like the beta for mutation, but we can use tooling like Caverno or OPA that we'll be seeing like in a couple of slides. So you have like all of that together in a single place. And combine it, it's what I just said. We have like this very large controller ecosystem that can go from resource creation, resource management, to policy enforcement, rules, and also like custom controllers, like as we can see on the top, like that can be like any custom resource definition that you can create on Kubernetes. So Kubernetes allows you to do all of that in just one place. So why not using that? Okay, Rodrigo, this is very interesting, but how does that really works? So if we take a look on like how Kubernetes works on the abstractions, you have like a single deployment, and you do like all the changes on that deployment. That deployment will generate replica sets, right? And then that will generate pods and eventually containers inside of it. And the beauty of that is the consistency. Like if you change anything on the pod itself, it will be overwritten, because the single source of truth for this is the deployment, right? So Kubernetes already has this consistent cycle embedded. So we can bring this to like a different level, right? So thinking the deployment would be like our application. Here we still have like the environment and the cloud that can be both ways. So we can have like your environment as a centralized place, and you can create cloud resources. But let's focus on the application side. So let's think that the application is our main package here. And from there, you can create like other resources. So you can have like network resources, you can have controls, rules, you can have like a Kubernetes cluster, or even like the security, which we'll be talking about. So everything here today like is about like security and velocity. So we can use Kubernetes constructs and Kubernetes visual cycle to do this kind of approach of like a platform engineering using this tooling and these native features that you have on Kubernetes. So we have like native security features. We have like RBAC, we talk about this. We have network policies and pod security standards that can be created like by namespace. So remember Raj mentioned like multi-tenancy and isolation. So if you have like just one cluster, you need to have like tenant isolation between the namespaces. So that's where you start implementing network policies and pod security standards. And then talking about security, we have like security as code. We have like native features, but we also have like the CNCF landscape. We have Kubernetes, we have like Kubernetes booth here, which is like a very powerful tooling for dynamic policy and access controls. And we have Cedar that I just talked about this. So Cedar is coming like very close to be like fully donated to CNCF and be present on a lot of clusters. Okay, so we have like this tooling, but how do we enforce that consistency? So GitOps, we all know like GitOps is there, and GitOps provides us this immutability firewall where our Git repository will be our single source of truth, the same as we have for the deployments, right? So if you change anything on your cluster that shouldn't be there, your GitOps agent, that can be any of the toolings that we will be talking about, like for example here, Flux or Argo, for example, that are operators for GitOps, they will return to the desired state of the cluster. And this is not like for platform engineering, for applications as we used to do. Like this can be empowering security. That's the goal. And this will make like this misconception that security will delay the velocity or like will slow down the velocity. No. If security is embedded with and packaged together with the application and the infrastructure resources, it will speed up the velocity. Like there's a study from CNCF from a couple of years ago that shows that to fix an issue on the production environment, like security issue on production environment, is 640 times more expensive than fixing on the development side. So if you fix that, like, and you have like all your environment like already enforcing security and policies, when you go to production, this will be faster and let's say like failure proof, right? So shifting left security, that's what we're talking about. So we have like every tooling that's available for the development side. You have like tools like Trivy or Gripe to do like scanning. You have ChainGuard to provide you like zero CV policies. You have like all the deployment part that we talked about, like GitOps toolings, OPA, Kyverno, policy engines, and then you have like runtime security like Kyverno, or even AWS-powered tooling like GuardDuty, for example. So you can cover all the security end-to-end if you implement the right packaging. So how do we do like this right packaging, right? So you need to start with a blueprint definition. So on the right-hand side, you have like all the resources, so platform resources in this case. You can see like cluster networking, rules, policies, RBAC, namespaces, all of those things, and a lot of them are security related. And you can see like even though that they are separated in different boxes, it's because they belong to different baselines. So you can have like required infrastructure that can be your underlying cluster and the things that are related to infrastructure overall. And also you need to baseline your Kubernetes approach. So how do you want to build your Kubernetes? So why those are separated? If you think about, for example, Terraform. Terraform is still like very popular for deploying infrastructure. But Terraform is not that good to deploy like Kubernetes-based resources. Come on, like there's this fist fight between them. Who owns the resource? So Terraform's try to destroy, and Kubernetes say, hey, no, this is mine, and it becomes a mess, right? So that's why you need to separate that. And then you can create like the packages. And this together will start creating what we call the aggregated module, right? But the aggregated module is not just the platform side. You have the application side. In this case, we're talking about Helm, but it can be KRO, for example. How many of you are aware of what's KRO? Okay, so for those who don't know, like KRO is a new way to deploy a Kubernetes resource. It has like this dependency tree, a bit different from Helm. Like it can be packaged as Helm, but it understands like the dependency tree. So for example, you can deploy several objects, several Kubernetes objects inside KRO manifest, and KRO will be able to understand, okay, I need to create first the deployment, then the service, then the ingress controller with the phasing, similar to what Terraform does, like from the dependency tree, but inside Kubernetes. So KRO is a very powerful and can be packaged together with Helm charts. And then you can expose like the application package for your developers as Helm values. So you can expose everything that they can customize from their side. So you don't need to expose everything. It's simplified to the dev team. And what if we package the security together? So that's the whole goal. Usually you see people like just packaging applications, deployments, but we're missing the security side. And then we need to implement security after everything's running. So that's the hardest part. That's why I can say that here, because there's no security, guys, since we saw in the beginning. But like that's what makes security so hard. And we say, hey, you're delaying our work. So with that aggregated module, you can have everything together. So the DevSecOps team can help you build that template together with the platform team. So together with that, you will just expose that through, like, for example, a Git repository. And that aggregated module will just be consumed. So much easier from team 1, team 2, team 3, like everybody can consume, and the DevSecOps team stop being that bottleneck. And security starts helping the velocity or speeding up the time to market and the deployment cycle. And all of them can deploy their applications like pretty easily. With that, you have like all the isolation, security, standardization, and consistency across your entire environment. And also like, okay, this can be applied to one cluster or several clusters. Remember Raj mentioned about tenancy? So you need to understand like what kind of multi-tenancy are we looking for? This can be applied to like multi-cluster if you have like a hard multi-tenancy requirement, or like namespace level where you have like one namespace shared across different teams, or even a cluster with different namespaces, or even the application level where you have like something that's completely shared. This can be adopted whatever the multi-tenancy isolation that you're looking for. And this will broaden your scalability and make your teams scale much more and with all the security embedded together. So you don't need to have like those issues like post-production environment. So we are on time, like key takeaways for today. So security enables velocity, not the other way. Like security is not there to slow down, but to speed up and to avoid like any consequences in the future. Shift left and automate everything that you can. So using a platform engineering, which is our third key takeaway, will help you speed up your deployment process, your life cycle, and also your security. And last but not least, test your security before someone else does for you. Like, because you want to be like completely safe before someone else tests that, hey, your environment's not really secure. So that's it for today. Like we have like I said, we have like all the slides, everything that's available on our GitHub, and I think we're open for questions. Do you still have time for the questions?
All right, looking for hands. Who's got a question? Right here.
Hey, thanks. Great presentation. Wondering about some best practices around how you version that top-level abstraction.
What do you mean, like for like the packaging? Like how do we do the packaging?
Yeah, so this top-level abstraction kind of has a bunch of other abstractions underneath it. Let's say one of the API versions of that lower-level abstraction changes. So how do you kind of bubble that versioning up to the top-level abstraction?
Okay, so you mentioned like if I need to do like an update on like something that's in the middle of that package, like how do I do that? So this is actually a very good point. Like, so how do I update across all of my environment something that changed in the middle of that abstraction? So that's why you need to enable like this kind of platform engineering and the versioning. So because you can use like version on Helm packages, for example, or even with other kinds of abstractions, images, whatever, you can do like rollouts phase using those new tags. So you can create a new release and do like a phased rollout across your entire environment, depending on how do you want to do it. So for example, you can do like a quicker one on development side, or like production, I want to do like a more gradual release. Does it make sense? It's basically what we call like it's similar to what a SaaS approach would be.
Any other questions? Going once? Got one? Switch it up.
Okay, and how about those teams that are handling over hundreds of clusters, and like we are upgrading our version of Keycloak, for example, across all of those clusters? Which are the best practices to like avoid downtime, but also don't having to update the values across all of those manifests? So we are like avoiding toil, basically.
So you mean like doing like the cluster life cycle or the application level life cycle?
I would say cluster, across the cluster life cycle. Mm-hmm.
So the cluster life cycle is kind of like a very discussion point. This is a question that we have like from several customers. You can do like basically the same approach if you're using an IAC packaging together. You can use like ACK or Crossplane or even Terraform with Flux. There's an operator with Flux that allows you to do that. You can use like the same approach for versioning. For package versioning, but the thing is like the question that we hear most from the customer is, okay, what if I have a big cluster or several clusters? What should I do? Like, should I do like soft multi-tenancy or hard multi-tenancy? So the multi-tenancy is more about like which kind of level of isolation do you need? Like customers that want like a PCI compliant cluster, they need to be fully isolated. And you can use the packaging side to onboard like different clusters and do the gradual rollout. But when you have like a bigger cluster, you have like very customized resources like CRDs, you need to onboard all of your teams together before you do the cluster upgrade. So the cluster lifecycle becomes one step before, where you need to make sure that all the applications are onboarded for the new version of the cluster. So you probably don't need to do like the packaging for the cluster, like the packaging approach with the versioning. But then you need to do like the application lifecycle and fix all the CRDs from the operators and all the versions before you do the cluster upgrade.
And what's your take on this approach where teams are building a control plane, like the parent of all of the clusters, and using like application sets to deploy those, let's call it general operational services, like they could be deploying Keycloak, GitLab, Nexus as application sets, so we are not repeating those deployments. But what's your take on if you think if it's a good or a bad practice?
So on the application sets, if we're talking about, for example, the operators, like you mentioned, like Keycloak or any other operator that's running on the cluster, using application sets. So for bigger enterprises, usually the best, not the best practice, but a good practice, it would be like separate. You're talking about application sets. I understand that you're talking about Argo CD. So usually we separate the Argo CD deployment, and the platform teams have one Argo CD just for operators that can be deployed across all of the clusters. Those application sets that will be like operators, but they're treated as application sets that can be replicated across the whole environment. So the development teams, the application teams are just responsible for the applications itself, not the operators. The operators will be all with the platform team, and that can be they can be packaged and using this like central Argo for the operator's life cycle. And then you can use like different Argo architectures. For example, the application team can use like a more agent with a pool approach that will bring the information from a centralized Git repository, wherever like the operators will be more a push approach, where you have like a central Argo that's pushing the changes to all the clusters, and it's easier to manage. So you have like a central Argo with just clients Argo, and the application teams will be responsible for the applications on their own clusters. Make sense?
All right, let's get another round of applause for Raj and Rodrigo.